Alright guys, I wanted to give you a first look at the migrations feature I've been working on for Truffle. The idea of migrations comes from Ruby on Rails, where you treat your database and your application as something that evolves over time. So even though you create a data structure and a database structure in the beginning, what that evolves into is something that you completely didn't expect. And so you need a function, you need a way to manage that change over time. And I've taken that idea and pulled it directly into Ethereum. Now, what that means for Truffle is that the previous deployment structure is completely gutted. So you don't use your configuration file to specify which contract gets deployed, because that doesn't uh, that doesn't scale well over time. You want to deploy, for instance, 5 functions initially, but what do you do when you want to upgrade those functions later, or upgrade those contracts later, or what do you do when you want to completely replace them, or deploy 3 new ones? Again, the configuration file deployment doesn't work too well. So what I built is a function to allow for scripted deployments, and I'm going to show that to you right now. So what I'm going to do is create a new Truffle project. So create a new directory, go into the test directory, Truffle init, and go ahead and init a new version of the app. And what you're going to see is this is a very different structure if you're used to Truffle projects. You have the app directory that it gives you and the contracts directory that it gives you, but instead of um, an environments directory, there's this migrations directory, and well, I guess the rest is the same. I'll get into how this changes. Another directory is going to pop up. This, if you're an avid Truffle user, this will change the directory structure of your project, and there will be some upgrading to do. But let's ignore that for now. What I'm going to do is head over to this migrations directory, and I'm just going to, it comes with some default migrations here. I'm just going to go ahead and remove those, because we're going to do this together. Okay, so to give you an idea of what we're working with, I'm going to hop on over to my text editor, and I have the application that we just created pulled up, and let's go over the contracts real quick. And notice that there are 3 contracts, and this is different if you're also familiar with the default application that Truffle gives you. The first contract is called MetaCoin, and this is just your very, very simple coin contract. In fact, it's so simple that it doesn't even support the general token standard that Ethereum uses. So all this does is allow you to is it creates this basic coin that starts with a balance of 10,000, allows you to send it from one address to the next, and then you can convert this to Ethereum with this convertlib library. And this is a good example because this contract uses a library, and that'll make our deployments complex enough, I suppose. So let's go over to this convertlib library. It just takes in conversion rate and amount and returns the value. Not too exciting there. There's one other contract here which is very important to this new feature, which is the migrations contract. And this contract will be deployed once unless you want to overwrite it later. And this manages which migrations have been run and records that on chain. So we'll get to what a migration is in a second, but this is an important contract and we need to have that. So when we move over to the migrations directory, remember that I removed them completely, and I did this because I wanted to write these migrations with you. So going over our contracts, what we have is we have a contract, we have a library that um, or sorry, the contract depends on this library, so the library needs to be deployed. And then we have this migrations contract, which as part of the feature needs to be deployed. So we have three things that need deployment, and they need deployment in a specific order because of the library. So what I'm going to do is I'm going to go ahead and create a new contract, new file, or excuse me, a new migration, and I'm going to call this. It needs to be a one base number, and I'm going to call it initial migration, and this is a JavaScript file. So what this does is it exports a function that's going to be ran that acts as the migration. So we're going to create our function here, export a function, and then we want to fill it. Now we have a couple options for what we can do here, but the migrations feature comes with a helper that allows us to script deployments very easily. So although you could write contract code here, or excuse me, you could write code that interacts with your contracts just like you would on the front end, the helper allows you to run migration steps in a way that makes it much easier to write and understand. So the helper is actually called deployer. We might rename this in a bit. But this, okay, so this is a piece of JavaScript code, and when it's run, Truffle makes your contracts available to this code. So the contracts we have are migrations, Metacoin, and ConvertLib. They're made available as contract abstractions through ether pudding. If you've used Truffle for a while, you should be familiar with that. And so what we can do is pass those to the deployer in order to deploy the contracts we want. So what I'm going to do is say deployer.deploy migrations. And what this is going to do is deploy the migrations contract. Now, notice that this function does not have a callback. It just runs synchronously. And if you use the deployer, what the migration does is doesn't actually perform any actions, any deployment actions on the network. Instead, it queues actions that will be run later. So this deployer is effectively our queue. So the first thing we're queuing is a deployment of the migrations contract. And we're not going for this migration, we're not going to queue up anything else. So that's our first one. And this is a special, as I mentioned before, this is a special contract, and each new Truffle project is going to get this. This migrations contract makes sure that once we run this migration on chain, we're not going to run it again. And it knows that based on its number here. We've numbered this the initial migration. And I'm going to go ahead and show that to you now. So I'm going to run Truffle migrate. Let's get out of this directory first. Truffle migrate. And it's going to go ahead and compile for me because I haven't compiled yet. And then it's going to go ahead and deploy migrations. We're going to see that here. So it's compiling everything, which it does first. And migration, invalid. Did I not save it? I did not save it. That makes more sense. Let's go ahead and run this again. So note that it's running this first migration. One of the things that we queued up was to deploy the migrations contract, and now we have that contract at that address. So what we're going to do here is, as I mentioned, this contract that we just deployed through the migrations feature is integral to the migrations feature running. So if we try to migrate again, it's not going to run this script because it has it on chain. It's not going to run this migration because it has recorded that we've already run this one on chain. Notice that it did nothing there. So let's go and we have our migrations contract deployed, but let's go ahead and deploy our next two contracts. And for this, I'm going to go ahead and create another migration. Call this to deploy contracts.js. And again, we're going to do create a function and export it. Have the deployer. But for this, we're going to do something different. Now, notice that the Metacoin contract, notice that the Metacoin contract depends on convertlib. So we can't deploy Metacoin without first deploying convertlib. And then not only that, we need to link convertlib's address to Metacoin before deploying Metacoin in order for the deployment to happen successfully. So what we're going to do first is, as we saw with the migrations contract, we're going to say deployer.deploy convertlib. And remember, this is queuing up a task. This is queuing up tasks to run in order. So the next thing we're going to do is have the deployer auto link. And this is a feature of the deployer itself. It will take any contract it will take all the available contracts and link all of them that need linking. So we'll see that Metacoin will, since we have deployed convertlib, Metacoin will be linked to convertlib. So you could also write this in a different way if you want to be very specific. You could say link, and I want to link convertlib, which is the convertlib library, to Metacoin. But autolink is easier in most cases. So we'll just stick with autolink. And then what we'll do next is deploy, nope, not the migrations contract, the Metacoin contract. And again, we're queuing these in order. So we deploy convertlib, then we autolink, then we deploy Metacoin. And let's go ahead and check out what that does. So I'm going to run migrate again, and notice that it ignored the first one because the migrations contract was on the chain. So what it's going to do this time is, now that number 2 exists, instead of doing nothing, it's going to run from number 2, and we'll see that here. Again, it's likely that I didn't save it. There we go. And it did exactly what we expect. So it first deployed convertlib, then it linked convertlib to Metacoin, and then that was part of the auto-linking process, and then it deployed Metacoin. So now we have a fully deployed coin contract, or excuse me, fully deployed test application with Metacoin, and we can be doubly sure that this deployment actually worked, and then we can run Truffle serve. Looks like I've actually broken that right now. I guess that needs to be fixed. Alright, so I fixed the bug, so we can go back to verifying that our migrations worked by running Truffle serve. What this is going to do is serve the application on port 8080. Very simple server. Let's go check it out. Localhost 8080, and see what we got. So we already know, if you're familiar with this application, then you already know it worked because we have that 10,000 Metacoin that the contract started with. So we can go double check and run a few tests by hand. So I'm going to send 95. Oops. I'm going to send 95 Metacoin to this random contract. And since we're using the test RPC, it's going to go very fast, but you'll notice that the transaction worked and was completed. So our deployment works. What can we do from here? I want to show you some other examples, or quick examples, to show you what this deployment process is capable of. So I'm going to create a third, oops, I had some other things open while I was trying to fix that. I'm going to create a third migration, and we're going to call this number 3, and it's going to be edit metacoin.js. And what I want to do is, a lot of people ask, or have previously asked on Truffle, how do we deploy complex contracts, or even less than that, how do we deploy contracts that have constructor parameters? And previously, through a configuration file, that was not possible, but this deployment scripts, or excuse me, these migration scripts make it very easy. And so what I'm going to do is I'm going to update the metacoin contract to take in another parameter. All right, so I've gone ahead and edited the metacoin contract so that it takes in a initial balance. And what we can do with this is we can deploy this contract and say, I wanted to start with this amount of metacoin. So we can go over to our third migration, which it looks like, wow, that was weird. I renamed this. I renamed the migrations directory instead of actually creating a new file. So let's go ahead and create a new file. 3 migration, or excuse me, edit metacoin. And then what we're going to do, again, just as before, module.exports equals function, take in a deployer, and then what we want to do is we want to completely override the metacoin contract. And to override it, we don't have to do anything different. Truffle and the deployer are taking care of the contract artifacts that get deployed. So you're using this to deploy singleton contracts. So contracts that only exist once for your application. For instance, for a token contract, or for a token application, it's really going to be one contract managing that token and how that token is getting passed around, at least for a simple token contract. So what we're doing in this deployment is we're completely overriding that simple token contract for one that's a little less simple. And since Truffle is managing this, all you have to do is just do deploy as you normally would, and it'll know that you are overriding a contract that has already been deployed. So we're going to do metacoin, but the thing is that if you remember, I added this constructor parameter, and we want to be able to pass a value. And so what you do is you pass these values to the deployer just as if you're calling the function. However, the first parameter is the contract that you want to deploy. So we're going to start this with 4,000 metacoin. So make metacoin a little bit more valuable with less supply. And what we can do is save that migration. And since, oops, I was serving over here. Since we had run the migration previously, it knows we have run migration 1. It knows we have run migration 2. And then what we can do is just run migrate again, and it's going to go ahead and run migration 3. And it's going to compile first because we changed some things. Oh, so that's interesting. We are overriding the metacoin contract. It got recompiled. Well, it should have stayed auto-linked, but perhaps it did not, so I'm going to go ahead and link those. This might be a bug. I'll look into it later. But just to be sure, we're going to go ahead and link it. Linking is just a string replacement on our side. It doesn't actually, linking doesn't happen on the chain anywhere. So we've auto-linked, we've deployed a new version of Metacoin. We can go ahead and Truffle serve again, and you'll notice that if this worked correctly, we're going to start out with 4,000 Metacoin instead of 10,000. So let me refresh this page. Well then, that's a problem. All right, problem solved. What is a demo without a few issues? So we're gonna go ahead. I had to go edit some things and change Truffle around a little bit. So let's go back to where we were here. Notice the Metacoin contract, just to make sure that we did things correctly. We're not hitting the default value. I changed the default value to 9,000 instead of 10,000. We're going to go ahead and migrate from the beginning. This is a feature that you'll likely use a lot during development. Migrate reset. That will go ahead and migrate directly from the beginning as if nothing happened. So we go and we do that. We get all the migrations run. Oops, Truffle serve. Well, I do that all the time. Truffle serve, and it's going to go ahead and build, run, go ahead and refresh, and we get 4,000 Metacoin, exactly how we expected. So to regroup, we overwrote Metacoin, stating that we want 4,000 instead of 10,000. Now, a couple things that we could do. I'm going to go ahead and show these to you by hand. I'm not going to be able to run them because we don't have the project for them. But one thing that the deployer supports is deployer dot. Actually, you know what? I can show you these. Let's go ahead and look at a different piece of code. It's the dApp store, which I have here. Let me go ahead and close all these windows. The dApp store has been configured to work with this new migration system. So if we go and look at the migrations that are available there, we have the same initial migration where we deploy the migrations contract, but we have a second migration which does a lot of complex things. So the first thing that we do is we deploy a library like we did previously in the Metacoin contract. We auto-link like we did previously as well, and then we actually deploy multiple contracts at once. Now, if you were to queue up multiple deployments with the .deploy function, it will run these deployments synchronously. So it will deploy the first, then deploy the second, then deploy the third. However, if you specify them as an array, it will do all these deployments at once. And so it's able to do this by because these contracts that I'm deploying here don't depend on each other. Now, in the case that you wanted to do multiple deployments at once, where they don't depend on each other, but you want to pass constructor parameters, just make this an array. So go ahead and array arg1, arg2, etc., etc., and that will work. Oops, let me put this back to where it was. So that's the deploy command. There's a second command, or another one, which is .then, which effectively lets you run anything at all. So in this case, we are pulling the model coordinator contract, setting up names to contracts, and then running functions, passing the ASCII version of that name and the contract address. So what's interesting here is that this code, as you can see, expects things to be deployed. So you have the deployed version of a contract here, for instance. And it can expect that because the previous step did this deployment. The code that runs in the .then function will run in sequence. So it can safely expect all of the things that happened previously to have happened before it gets run. So so remember, the deployment, the execution time of this is not during this function, is not during the migration function itself. Rather, it's after everything gets queued up and after the steps before it get run. So another nice one is .exec. You can execute any JavaScript file. Actually, that's a bit overgeneralization. A JavaScript file that's written in a specific way that exports a function. You can run that function as a deployment step here. And there's one other tidbit to this. When we're running on the default network, and I haven't gotten into networks yet, but when we're running on the default network, which for this project, that network is the deployment or is the development network. Let's add some demo data, and this adds some nice data to work with. So for development and testing. So and notice that we get this network value as a second parameter to this migration. So in the previous examples I've shown you, you can or you've only seen the deployer, but you can get a second value called network to know which network you're running on. And that's actually something that I'm going to have to use likely a new video or documentation to talk about. The general idea, however, is previously your contracts were stored in different environments, and as you can see from the dApp store here, these environments still, the dApp store has saved these environment directories. They're no longer being used in this new version of Truffle. Instead, everything is saved within the contracts itself, and the contract files, the .sol.js files, store the artifacts for each contract relative to each network. So you, in this case, in this new version of Truffle, you only need to require one file, and it will talk to the chain, it'll talk to the Ethereum client, and it'll know which network it's running on. And once it figures out which network it runs on, it uses those contract artifacts, uses the correct contract artifacts per network. So need to flesh that, or I need to describe that in more detail, and so that will come soon. However, that is the migrations feature. I hope you enjoy.